Have you ever noticed how music can suddenly sound louder, richer, or clearer just by changing the room you're in? You sing in the shower and boom, you sound like a superstar. You step into a dome, clap your hands, and the sound seems to float forever. No speakers, no amplifiers, just shape. So what's going on here? Why do certain shapes naturally amplify music?
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
Let's start with the basics. Sound is vibration. When something vibrates, like a guitar string, a drum skin, or a human voice, it pushes air molecules back and forth. These vibrations travel as sound waves. Now here's the key idea. Sound waves don't just move forward. They bounce, reflect, bend, and sometimes even pile up. And the shape of the space they're in decides what happens next. Imagine throwing a bunch of rubber balls into a room. In a square room, they bounce around randomly. But in a curved room, something interesting happens. The balls tend to gather in certain spots. Sound behaves in a very similar way. One famous example is a dome or circular wall. In these shapes, sound waves reflect along the curve instead of scattering evenly. Because of this, the waves can stay concentrated and travel farther with less energy loss. This is why whispering galleries exist. Places where a whisper on one side of the room can be heard clearly on the other side. The shape guides the sound, almost like invisible rails. Curved surfaces don't just reflect sound, they can also focus it. Think of a satellite dish or a flashlight reflector. These shapes are often parabolic, meaning they're designed to redirect waves toward a focal point. When sound waves hit a similar curved surface, they can converge at specific locations, making the sound much louder there. You didn't raise the volume, the geometry did. Now let's talk about cones and horns, especially in music. Brass instruments like trumpets and trombones don't just look fancy for style points. That flared bell at the end is doing serious physics work. Inside the instrument, sound waves bounce back and forth. The horn shape helps match the vibrating air inside the instrument with the air outside. This process, known as acoustic impedance matching, allows more sound energy to escape into the room, instead of staying trapped inside the instrument. The result? Louder, clearer sound. This principle isn't limited to instruments. Early megaphones, gramophones, and even some modern speakers use horn shapes for the same reason. The shape doesn't create energy, it simply helps transfer energy more efficiently. Another powerful shape is the cavity. When sound enters a hollow space of a certain size, it can resonate. Resonance happens when sound waves bounce back and forth at just the right timing, reinforcing themselves. The waves line up, add together, and grow stronger. This is why bottles whistle when you blow across them, and why rooms with certain dimensions seem to favor specific notes. Your shower is a perfect example. Its small, enclosed space reflects sound rapidly, and some frequencies resonate more than others, especially those in the human vocal range. To your ears, your voice sounds fuller and louder. Sadly, the physics does not follow you onto the stage. But not all shapes amplify sound in a pleasant way. Some shapes cause echoes, muddiness, or uneven loudness. That's why concert halls are carefully designed using a mix of curves, angles, and textured surfaces. The goal is balance. Amplify the sound without distorting it, and spread it evenly so everyone hears the music clearly. What's fascinating is that none of this requires electronics. Long before modern technology, architects and instrument makers understood, through experimentation, that shape controls sound. Today, acoustic science confirms what they discovered by ear centuries ago. So the next time music sounds magically louder in a certain space, remember, it's not magic. It's geometry, physics, and sound waves working together in perfect harmony. Now here's a question for you. What place have you been to where sound felt surprisingly powerful or strange? And why do you think that shape made the difference?
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.